Space is full of wonders. There are black holes, exploding stars, and even tornadoes. These phenomena are not just fascinating to look at, but they also help us understand the universe better. Each of these cosmic events plays a crucial role in the grand tapestry of space. Yes, you read that right, space tornadoes. These are not your typical tornadoes that we experience on Earth. They are far more colossal and powerful, swirling with cosmic gas and dust. These tornadoes are not like the ones we see on Earth. While Earth tornadoes are formed by weather patterns, space tornadoes are driven by the intense gravitational forces and magnetic fields in space. They are much bigger and more powerful. Imagine a tornado that spans light years across and contains the energy of millions of stars. That's the scale we're talking about. Scientists recently discovered these space tornadoes in the Milky Way galaxy. This discovery was made possible through advanced telescopes and space observatories that can detect the faintest signals from the farthest reaches of our galaxy. These tornadoes are located in a region called the Central Molecular Zone, or CMZ. The CMZ is a dense and dynamic area filled with molecular clouds and star-forming regions. The CMZ is a busy place. It's a hub of activity where new stars are born and old stars die, contributing to the ever-changing landscape of our galaxy. It's full of gas and dust. These elements are the building blocks of stars and planets, making the CMZ a crucial area for understanding the life cycle of celestial bodies. This is where stars are born. The intense gravitational forces in the CMZ cause the gas and dust to collapse and form new stars, some of which may eventually host planets. The discovery of space tornadoes is exciting. It opens up new avenues for research and helps us understand the complex dynamics of our galaxy. It tells us more about our galaxy. Each new discovery adds a piece to the puzzle, helping us understand the intricate workings of the Milky Way. It shows us that the universe is a wild and wonderful place. The more we explore, the more we realize how much there is to learn and discover. In this essay, we will explore these space tornadoes. We will delve into their formation, their composition, and their impact on the Milky Way. We will discuss how they form and what they are made of. Understanding these cosmic phenomena can provide insights into the forces that shape our galaxy. We will also examine their role in the Milky Way. These space tornadoes are not just fascinating to observe, they play a significant role in the dynamics of our galaxy, influencing star formation and the distribution of cosmic material. The Milky Way is our home galaxy. It's a spiral galaxy, a vast collection of stars, gas, and dust bound together by gravity. The Milky Way is just one of billions of galaxies in the universe, but it holds a special place in our hearts because it's where we live. Our Sun is just one of billions of stars in the Milky Way. Each of these stars has its own unique characteristics and potential planetary systems, making our galaxy a diverse and dynamic place. At the center of the Milky Way lies a mysterious region. This area is shrouded in intrigue and has been the subject of much scientific study and curiosity. We call it the Central Molecular Zone, or CMZ. This region is crucial for understanding the dynamics and evolution of our galaxy. The CMZ is a very dense place. It's packed with a high concentration of molecular clouds, which are the building blocks of stars and planets. It's packed with gas and dust. These materials are essential for the formation of new stars and planetary systems. In fact, the CMZ contains most of the Milky Way's molecular gas. This gas is the raw material from which stars are born. This gas is the fuel for star formation. Without it, the process of star birth would come to a halt, and our galaxy would be a much darker place. The CMZ is a turbulent place too. The constant movement and interaction of gas and dust create a chaotic environment. Clouds of gas and dust are constantly moving and colliding. These collisions can trigger the formation of new stars or lead to the destruction of existing ones. This makes the CMZ a very chaotic environment. The constant flux and change make it a fascinating area of study for astronomers. But this chaos is also what makes the CMZ so interesting. The dynamic interactions and ever-changing conditions provide a wealth of information about the life cycle of stars and the evolution of galaxies. It's a place of birth and destruction. The CMZ is where stars are born and where they die, making it a region of both creation and annihilation. It's where stars are born and where they die. The life cycle of stars in the CMZ provides crucial insights into the processes that shape our galaxy. The discovery of space tornadoes in the CMZ is just the latest in a long line of surprises. These tornadoes are massive, swirling structures of gas and dust that add to the complexity of this region. It seems that the more we learn about the CMZ, the more we realize how much we don't know. Each new discovery opens up more questions, making the CMZ one of the most intriguing and mysterious regions of our galaxy. So, how did we find these space tornadoes? Astronomers were using a powerful telescope. It's called the Atacama Large Millimeter Submillimeter Array, or ALMA. ALMA is located in Chile. ALMA can see things that other telescopes can't. It can see through the gas and dust of the CMZ. This is how astronomers discovered the space tornadoes. They saw long, thin structures. These structures are called slim filaments. The slim filaments are made of gas. This gas is moving very fast. It's spinning around like a tornado. The filaments are also very hot. This heat comes from the friction of the gas moving so fast. The discovery of slim filaments was a breakthrough. It was the first time we'd ever seen anything like this in space. It's a reminder that the universe is full of surprises. These slim filaments are not just sitting still, they're moving and changing all the time. They're like dancers, twirling and spinning through space. But their dance is not random. It's controlled by the forces of gravity and magnetism. The filaments are stretched and pulled by the gravity of the black hole at the center of the Milky Way. This gravity is what gives them their shape. The filaments are also affected by magnetic fields. These fields can twist and turn the filaments, making them spin even faster. The combination of gravity and magnetism creates a beautiful and chaotic dance in the CMZ. The dance of the slim filaments is a sight to behold. It's a reminder of the power and beauty of the universe. Section 5. The recipe for a space tornado. How do these amazing space tornadoes form? The process is as fascinating as it is complex, involving a series of cosmic events that culminate in these awe-inspiring phenomena. Astronomers think they have a pretty good idea. Through years of observation and research, they have pieced together the steps that lead to the formation of these cosmic whirlwinds. It all starts with the turbulent environment of the CMZ. This region, located near the center of our galaxy, is a hotbed of activity, filled with dense gas clouds and intense gravitational forces. As we learned earlier, this region is full of gas clouds moving at incredible speeds. These clouds are constantly jostling and colliding with each other, creating a chaotic environment. When these gas clouds collide, they create shock waves. These shock waves are powerful disturbances that propagate through the gas, compressing and heating it as they go. These shock waves are like the sonic booms from a supersonic jet. Just as a jet creates a loud boom when it breaks the sound barrier, these shock waves create powerful bursts of energy in space. They're incredibly powerful and can heat the gas to millions of degrees. This intense heat causes the gas to become highly energized and start to rise. This heated gas then starts to rise like hot air from a fire. As it rises, it begins to cool and condense, forming new structures in the process. As it rises, it starts to spin, just like a tornado on Earth. This spinning motion is driven by the conservation of angular momentum, a fundamental principle of physics. The spinning gas forms the slim filaments we see with ALMA. These filaments are the precursors to the full-fledged space tornadoes, marking the early stages of their formation. These space tornadoes are a testament to the power of nature. They demonstrate the incredible forces at work in the universe and the dynamic processes that shape our galaxy. They show us how even in the most chaotic environments, order can emerge. These cosmic whirlwinds are a beautiful example of how the universe can create structure and beauty from chaos. Section 6. A cosmic cycle. Recycling in the CMZ. Space tornadoes play a vital role in the life cycle of the CMZ. They act like giant recycling centers, taking old, used-up gas and dust and giving it new life. Remember how we said the CMZ is full of gas and dust? Well, this material is constantly being used up to form new stars, but the space tornadoes help to replenish this material. They do this by pulling gas and dust from the outer regions of the CMZ towards the center. This brings fresh material into the star-forming regions, allowing the cycle of starbirth to continue. Without these space tornadoes, the CMZ would eventually run out of fuel, and star formation would cease. Thanks to these cosmic recyclers, the heart of the Milky Way continues to beat strong. Section 7. ALMA, Our Eyes on the Universe. The discovery of space tornadoes wouldn't have been possible without the incredible power of ALMA. This telescope is a marvel of engineering, located in the high Atacama Desert of Chile. It's one of the most powerful telescopes ever built. ALMA is actually made up of 66 individual telescopes that work together. These telescopes are spread out over a large area, which gives ALMA its incredible resolution. ALMA observes the universe in millimeter and submillimeter wavelengths. These wavelengths are invisible to the human eye, but they carry a wealth of information about the universe. By observing in these wavelengths, ALMA can see through the gas and dust that obscure our view of the CMZ. It's like having X-ray vision for the universe. Section 8. Unveiling the Secrets of the Milky Way. The discovery of space tornadoes is just one example of the amazing discoveries being made in astronomy. With powerful telescopes like ALMA, we're able to peer deeper into the universe than ever before. We're learning about the birth and death of stars, the formation of galaxies, and the nature of black holes. Every new discovery brings us closer to understanding our place in the cosmos. The Milky Way, our home galaxy, is no longer a complete mystery. We're starting to unravel its secrets, one discovery at a time. The future of astronomy is bright. With new telescopes and instruments on the horizon, we're poised to make even more groundbreaking discoveries in the years to come. Section 9. Conclusion. The future of space exploration. The discovery of space tornadoes is a testament to the power of human curiosity. We've always looked up at the stars and wondered about our place in the universe. Now, with powerful telescopes like ALMA, we're finally starting to get some answers. But with every answer, new questions arise. The universe is full of mysteries, waiting to be uncovered. It's up to us to continue exploring, to keep asking questions, and to never stop searching for knowledge. The future of space exploration is bright. Who knows what other wonders await us out there in the vast expanse of the cosmos? One thing's for sure, the journey of discovery is just beginning.